Good morning, Geometry Honor students. So this is Mr. Chen again. So today I just want to continue to talk about that Unit 2. So this one's supposed to be Section 2.2, but somehow it's the same lecture from the other textbook there. So using inductive reasoning to make conjecture. So let's start it off with this, the first slide right here. There's some of the warm-up problem that you guys can try. So blank points are points that lines on the same line. So this one can say that what? Collinear points. And then points are points that line in the same plane, coplanar, right? And then the sum of the measure of two blank angle, it's 90-degree complementary angles. Okay, so that's something you guys can just refresh what we talked about recently. Okay, so now let's get started with the objective for the new lesson today. So use inductive reasoning to identify pattern and make conjecture. Find counterexample to disprove conjecture. Okay, so we're going to find out what those vocabulary words. Okay, so inductive reasoning, conjecture, counterexample. So here's the first example. So identifying the pattern. So find the next item in the pattern. So this one January, March, May. So this one it's just like what the pattern is showing every other month, right? So the next one would be considered July. And here's another one. So 7, 14, 21, 28. As you can see that the pattern here. So for those you were thinking about back to Algebra 1, it's arithmetic sequence. It is. So this one, the increment, is just by adding 7. So 7 plus 7, you got 14. 14 plus 7, you got 21. 21 plus 7, you got 28. So it's a consistency increment. So 28 plus 7, so the next number would be considered 35. And finding the pattern for the triangle, the direction. As you can see that the triangle right here looks kind of like isosceles. So this one has been rotated counterclockwise by 90-degree. And then 90-degree counterclockwise. So see that the vertex is facing down for the third one. So that means the next one, so the triangle, the vertex should be facing to the right. So rotation 90-degree counterclockwise. So one of the unit, we'll get to that for transformations. It's like reflections, rotations, translations, and also we'll talk about the other one. It's like one of the non, it's not part of the pattern there. It's like a dilations or the enlargement or the shrinking. Okay, we'll get to that. One of the unit. So here's more example that you guys can apply for doing the practice. So the decimal point, so 0.4, 0.04, 0.004. So the next one will be 0.0004. Okay, so more example for this. So inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. So you may use inductive reasoning to draw a conclusion from a pattern. A statement you believe that to be true based on the inductive reasoning is called a conjecture. Okay, so conjecture. So the sum of two positive numbers is, well, this one you want to come up with some example first. So let's say that positive number, we do have 1 plus 1, that's 2. 3.14 plus 0.01, decimal, 3.15. 3,900 plus 1,000, 1,017. So it's 1,003,917. As you can see that all those numbers there, once you combine all the positive number, the result is always considered positive. So this one you can just say that the result is positive. And here's another one. So the number of lines formed by 4 points, no 3 of which are collinear. So this one, draw 4 points and make sure that no 3 points are collinear. Count the number of lines formed. So let's say AB, AC, AD, BC, BD, CD. And the number of lines formed by 4 points, no 3 of which are collinear. So then that'll be 6. So just saying that the number of lines that's being formed. You can always draw that, you know. So 1, 2, 3, 4, 5, 6. So that's going to be 6 different lines right there. And here's more example. The product of two odd number, it's always, well, odd numbers like what, 1 times 3. Product, that means you multiply. So 1 times 3, that would be 3. 3 times 5, 15. 5 times 7, 35. So all the odd numbers, so once you multiply two odd numbers, the result is always odd. Okay, so always giving you the supporting examples. Okay, so here's another one. So biology applications. So the cloud of water leaving a whale's blow, the blowhole. When it exhales, it's called its blow. A biologist observed blue whale blows of 25 feet, 29 feet, 27. So this one shows you the data. Another biologist record that humpback whale blows of 8 feet, 7 feet, 8 feet, 9 feet. So make conjecture based off the data. So this one you just want to compare the list of all those data. Okay. And then the smallest blue whale blow 24 feet. It's almost 3 times higher than the greatest humpback whale blow 9 feet. So possible conjecture. So the height of the blue whale's blow is about 3 times greater than the humpback's whale's blow. And the height of the blue whale blow is greater than the humpback's whale blow. Okay? So whatever the pattern that you find out there, so that comes up with the conjecture. So here's another example. Comparing that, the average whale length. Okay? So female whales are longer than the male whales. So in order to show that the conjecture is always true, so you must prove it. Okay, yeah. So to show that conjecture is false, so you have to find only one example in which the conjecture is not true. So this one is called a counterexample. So a counterexample can be drawing a statement or a number. So inductive reasoning, always look for a pattern, make a conjecture, and number 3, prove the conjectures or to find a counterexample. So show that the conjecture is false by finding the counterexample. So for every integer n to the power of 3, it's positive. Is that always true? Well, you just pick any integer. So n equals 1, so n to the power of 3, it's 1. So that means 1 is greater than 0, so the conjecture holds. But the thing is that if n is negative 3, again, integer, it could be positive or negative. So negative 3 to the power of 3, then that would be negative 27. But negative 27, it's not greater than 0. It's less than or equal to 0. So the conjecture is false. So n equals negative 3, that would be a counterexample. So you want to show that the conjecture is false by finding a counterexample. So two complementary angles are not congruent. So 45 plus 45, that's 90 degrees. But also this one could be written as, well, it could be like 30 plus 60, then that would be true. But the thing is that those two angles could be congruent as well. So 45 plus 45. So show that the conjecture is false by finding the counterexample. So the monthly high temperature in Abilene, it's never below 90 degrees Fahrenheit for 2 months in a row. Okay, so as you can see that January all the way to December cannot be below 90 degrees. 2 months in a row. So this one is already considered false. From January, February, you see that the temperature is always considered less than 90 degrees. So that would be 2 consecutive months. Okay. And here's more examples for finding the counterexamples showing that the proof for the conjecture. So for any real number, x squared is greater than or equal to x. So let x be 1/2. So x squared, 1/4, it's not greater than 1/2. So the conjecture is false. Show that conjecture is false by finding the counterexample. Supplementary angles are adjacent. Not necessarily. Sometimes they can be separated. Adjacent, that means the angles, they're right next to each other. So this one, as you can see that the ray here, so they're parallel, so they're never being overlapped here. So that's why they're not considered adjacent angle. Okay, so more example that I can use for finding that, doing the proof for the conjecture. So here's the lesson quiz or the homework that you guys can practice with. So finding the next item in each pattern. So quite similar to what we talked about for the notes. So check it out. So the decimals, so moving the decimal point, the rotations with the arrow. Determine each conjecture is true. If false, give a counterexample. Okay, so once you're done, you can always check your work. Alright, thank you for watching the video today. So I'll see you guys next time. Again, if you guys do like the video and also subscribe to the channel, please. Alright, thank you. So I'll see you guys for the next video. Take care.